No, because 10 is not a multiple of 3.
You got a 5?
See, what would 3 be? 3, 6, 9. You with me?
Yeah.
What would 5 be? 5, 10, 15.
15.
Yeah, it's like an LCD, right? Sort of. But what's 1/3 times 1/5? 1/15. So 1 out of 3 steps, 1 out of 5 steps, 1 out of 15 steps. Right?
Okay. Yeah.
This time, one time I really went for it. I was like, damn. So I'm sorry, that's a silly example of finding the probability of something and something else is basically multiply. And on the surface, that seems weird, because what's and supposed to do? Decrease the probability, right? And we normally think of multiply as getting big, right? What's 2 times 8? 16, right? But what's 0.1 times 0.1? 0.01. So anything between 0 and 1, when I multiply them, they get smaller. You guys kind of with me? So multiplying probabilities make them smaller. That matches up with the and bouncer being mean, letting less people in. Maybe? 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 Okay. All right. So let's get away from blowing shovels up and slapping myself on the cheek. Let me write this down again because I just erased it. Good job. So algebraically, I can figure out what the probability of A and B is right now. I really can. How do I solve for the probability of A and B?
Oh, you multiply.
Yeah, get rid of P and B, get
yeah.
rid of the peanut butter.
And then that's
Prince's bubblegum. Multiply by PB. Is that cool?
Yeah.
So probability of A and B
times P.
equals probably A and, yeah, A. Probably, let me do it this way. Probability of B times probability of A given B.
Oh, okay.
Doesn't that match up with what we just figured out? And basically means multiply. Okay. Anybody else hot, or is it just me? I gotta make sure. Is it warm in here?
I think it's just.
A little bit? Okay, I'm just gonna give myself. Let me see if I can control it. I can control it. Ah, shit. I can't control it. Damn, you guys. Oh. Oh, that was evil. Oh. I can't control it. Oh, well, I'll just live with it. So let's try an example of this. I want to show you why this is a given right here. That's the part that didn't really show up. Okay. Oh, by the way, the thing I forgot to say about the space shuttle, why did the O-rings fail that day? Because that morning was icy. And unfortunately, the people with the space shuttle, NASA, was a little arrogant because they were like, well, we got this thing figured out. We shot this thing off so many times. It's icy, who cares? We're good. But the iciness actually made the O-rings' probability to fail go way up. And so that's what they did. All right. So anytime you're in that situation, don't shoot that shuttle off. So anybody really bad with cards? Like, do you guys know how many suits are in a deck of cards? What are they? Hearts.
Oh,
You guys know this. Hearts, diamonds,
spades,
spades,
and
clubs. Right? Not clovers. We're not talking about Lucky Charms. Yeah. I like.
I like Lucky.
You guys with me? Everybody knows that much, maybe. Right? So they're in cards. How many cards are there? 52 total. I had an older sister, so I know 52 card pickup. Jeff, 52 card pickup. You just throw the deck around. You got to pick them all up, or she's going to punch the shit out of you. 52 cards, 4 suits. So it's going to be 13 of hearts, 13 diamonds, 13 spades, 13 clubs. Right? Because 52 divided by 4 is 13. And they go from ace, let's say ace is low, up to jack, queen, king. All right, how we doing so far? They're just beautiful for probability questions. So let's say I have a deck of cards, and I want you to pick one card, right? What's the probability you pick a king? Yes, good. The big mistakes I get is somebody tells me 1 out of 4. That would only make sense if I said, I got a king. What's the probability it's the king of hearts? That would be 1 out of 4. But you're picking any card. So how many cards could it be? 52. And how many match what I'm looking for? 4. No, carefully. Not all kings, or else I'm not going to watch any magic trick you got. Well, it's a king. It's me. You guys with me so far? And of course, what is that? That's 1 out of 13. What does that mean? Sometimes when probabilities reduce, they mean something physically. For every 13 cards, there's 1 king on average, right? 1 king per 6. Okay. And then that is, what is that? That's like 0.07 something.
Yeah, 69.
Okay. All right. Now, if I pick 2 cards, and I'm going to do it with replacement. So what does that mean? If I pick 2 cards with replacement, it means I pick a card, look at it, and then I put it back in the deck. And then I'm going to pick another card. So could I pick the same card twice? Yes. So here's the trick. Probably pick 2 cards. Let's probably pick a king and then another king. All right, so here's how this works. This is like having multiple O-rings in a row. It's probably that they all fail. I'm going to multiply, right? So here I'm picking 2 cards. It's probably that they're both kings. That one and that one. I'm going to multiply 2 things. What's probably the first card is a king? 4 out of 52, right? And then I put it back in. So the first card being a king is 4 out of 52 times.
4 out of 52.
Yeah, what's probably the next card's a king? Still 4 out of 52. It's 0.05. Point oh oh
59.
5? 9? All right, now watch this. Does everybody see that? So if I would have picked 3 cards, which probably they're all kings, it would have been 4 out of 52 times 4 out of 52 times 4 out of 52. If I pick 3 cards, you guys see what I'm saying? Right? So this is not crazy. So let's do another one with 2 cards. Let's probably pick an 8 and then an ace. It's going to be kind of boring, but let's do that. Let's probably pick an 8. 4 out of 52. And then an ace. Yeah. So it's going to be the same amount. 0.0059. Okay. That kind of makes sense. If I pick any 2 cards, I got that probability of them being specific things. Yes? Oh, you good? Okay. So, here's the difference. Here's the thing. Really, well, I'm going to rewrite it. So what is the probability if I pick 2 cards without replacement? What's the probability I get? Let's do the last one. An 8 and then an ace. So now I'm doing it without replacement. I pick a card and I feed it to my little brother.
4 out of 52.
Got a lot of plastic in his diet.
Multiplied
Yeah, so the
by
probability first one's an 8 is 4 out of 52, but then I throw it away.
3.
Right? I feel like I'm Gambit.
3 out of
Charge it up and throw it. If you don't get that, it's okay.
It's still 4, no?
Still 4 aces, right?
Yeah, it's
Out of
gonna be
51.
A instead.
Out of 51 cards now. Does that make sense? Because if I do it without putting the card back in, I got less cards.
But if it was just like kings, Then
And we'll get there.
second one.
So look what we just did. What's 4 out of 52? It's an 8. What is 4 out of 51? Is the probably is an ace given that I just picked an 8. That is the formula. So why did the O-rings not change? Because the failure of one should not affect another one. They should be independent from each other. On the day that it was icy, there was something that made them all fail more. Anyway. Maybe. What about the kings then? Let's probably get a king and then another king. Oh, this will be, whatever this is, real quick. What is that?
Oh, the answer.
So it's maybe 6 something maybe, or
8.0060.
really? Okay. I thought it'd been a bigger difference. Oh. So what about this one? Was probably that you got a king first.
4 out of 52.
Yeah, in fact, what I often do is this. It's like a little hangman game. I got 2 spots, something and something else. The probability of first guy is 4 to 52. Then I throw that one away.
Okay.
Let's probably get another king now.
3
How many
out of-
kings are left?
3
3
out
Out
of
of-
51.
51. And that one's definitely going to be different. .0045? And that definitely changed quite a bit, right? Okay. Woo! So, let me finally shut the hell up. I want you guys, let's see. Definitely do the first problem at least. But I want you to try the second problem also. Second problem is like the ones we just did. Oh, by the way, one side says this side in class. And the other side is actually a practice quiz that I'll have an answer key for. Oh, shit. So I missed them. Missing person. So the side that says this side in class, definitely try to get the first problem done.